This is Unit 3, Video 5. In this video, we'll talk about Bohr's atomic model. Now, we said that Bohr was one of the discoverers, or he's one of the first to come up with the proper understanding of how the atom is laid out. And he said that electrons, specifically, electrons move around like planets around the sun. They move around the nucleus. Here's the electron. Move around the nucleus like planets around the sun in circular orbits at different levels. And this is a really good conception of the way an atom works. And here we'll see why he came up with this idea. Now, every energy level, here it says amounts of energy separate one level from another. Now, energy came from light. Remember that when we talked about light, we said that light has different forms of energy. And so he theorized that the electrons exist in these different energy levels. Now, the higher you are away from the nucleus, the further you are away from the nucleus, like this electron here, the more energy you have. So this electron actually has more energy as compared to an electron that's further in. And there is no such thing as an in-between energy level. This is kind of like the rungs of a ladder. You can step on these rungs, on these levels, but you can never step anywhere between the two levels. An atom is set up the same way. There is no such thing as an in-between energy level. So an electron cannot exist here. It can only exist in these specific energy orbits. Now, the way we came up with this is we first take an element and heat it. Here is an element that's been heated. As it's heated, it begins to glow, which means it begins to give off light. If this light is taken and separated into its individual colors, what you get is something called an emission spectrum. The emission spectrum actually shows the individual colors of each of the lights. And so here, for example, you see a lot of lines. If you count these lines, there's a bunch of lines that are released. And these lines, as you'll see, will be related to the electrons. So how is this produced? How are these lines produced is the question. And the way they're produced is through a story that we'll tell here. So first of all, when an electron absorbs a specific amount called a quantum is a specific amount of energy, it moves further away from the nucleus. It gets excited, so the electron is now in an excited state. That's what you see happening here. You have a lower orbit, the electron gets excited and moves to a higher orbit. Now, it can't stay there, so the electron falls back down, and as it falls back down to a lower energy state, it releases or emits a photon. And the frequency of this photon, in other words, how much energy it has, the frequency corresponds to the energy difference between the levels. So if you have an energy difference here that's small, then you have a light photon with a small frequency. If the energy difference is large, then you have a light photon with a large energy. And that's really how it works. So each element has a different arrangement of electrons, and so each element gives off a unique color spectrum. So here you see, for example, if this were the element krypton, and we'll say this is the element xenon, you see that to your eye, they kind of look the same. Both of them have purple light coming off of it. But if you analyze that light, you'll see that the spectrum is different. The lines are in a different spot, and the lines are a different intensity, which means every element has a unique color spectrum. The first color spectrum that everyone learns about is the hydrogen emission spectrum. So here is hydrogen being given off. And if you take a look, they put hydrogen and let the hydrogen glow. Now, the hydrogen usually has like a bluish, purplish glow. So if you take a look at it, it looks a little reddish, bluish, kind of a combination of both of those. And then if you analyze its spectrum, what you'll see is you'll see a red line and you'll see a blue line. Now, if you really observant, you'll also see a little green line. And this is because if we take the light and split it through a prism, its energy levels essentially are evident. These are actually the energy levels of the hydrogen atom. So you're actually able to see inside of an atom using this method, which is pretty fascinating. The numbers out here are the wavelengths, so this is in nanometers. Wavelength is given in nanometers again. Now, the number of levels is related to the number of electrons. So here, in the first level, for example, the first level of the atom can hold 2 electrons. The second level can hold 8. the third can hold 18, and the fourth can hold 32. These are interesting numbers, and they can actually be placed in an interesting equation, a really simple equation, 2n squared. So if you have energy level 3, for example, you put that into this equation, you do 2, n is the energy level. Notice here n is the energy level. If you put 3 inside of here and you square that, and then multiply by 2, remember order of operations says you square first, that gives you 9. So 9 times 2 gives you 18, and that's how you get 18 electrons in the third energy level. Really simple equation to tell us how many electrons are in a certain energy level. So now we can actually draw the Bohr model for one of the elements. Let's do the element silicon. Now the first thing to do is to find silicon on the periodic table, and you'll find that silicon is element number 14, which means it has 14 electrons. Because remember, atoms have the same number of electrons as they have protons. This is electrons, and it's also protons. Rather, I should say or protons, since you don't add them up. Right, so now we're going to draw the Bohr model. Let's go ahead and draw plus 14 protons in the middle. On the outside, we're going to draw energy levels. Let's go ahead and draw a few energy levels. Now, since we have 14 electrons, looks like we'll need probably 3 energy levels. And you can go ahead and draw a few energy levels and then put the electrons in there and remove them as needed. Now, the first energy level, if you take a look at the previous slide, has 2 electrons. So we're going to draw 2 electrons in on the first energy level, and I'll draw them in as little minuses. The second energy level can hold 8 electrons. So I'll go ahead and draw 8 electrons. I'll be drawing them on opposite sides. Notice I'll put them evenly distributed. Technically, you'll see that electrons actually exist in pairs, and eventually you'll see that they're existing in pairs. So I'll go ahead and put them in pairs here. That gives me a total of 10 electrons, and I'll make little negatives here to show that these are negatively charged. All right, I've got 10 electrons. I need a total of 14, so I'll put 4 more. Now, what I'm going to do is actually put 4 more before I double them up. So here it is. I've got 14 electrons in 3 energy levels. So this is specifically the Bohr model for the element silicon. Hopefully you followed me along, and these energy levels have to hold the right number of electrons. You can't put more than 8. You can only have 8 in the second energy level, for example. You cannot have more than 2 in that first energy level. And the third energy level, remember, holds 18 total. So you cannot have more than that. So go ahead and draw one on your own. Draw problem 6. Try fluorine. Do the same thing with the element fluorine. And now, let's show you how the periodic table can actually help you do this. So here it says the periodic table can help you draw the Bohr model more correctly. The periodic table has been arranged in a way to help you see the energy levels. In fact, if you take a look, the first energy level here, these are energy levels. The numbers on the left are energy levels. You have the third, the fourth, and the fifth. If you take a look at the second energy level, for example, you'll see it has 1, 2, 3, 4, 5, 6, 7, 8 elements in it. And that's because the second shell has 8 electrons. So we're going to use this to get and draw the electrons a little more precisely, because the way the Bohr model is filled up is actually according to the periodic table. What you'll see is that you have 2, 3, 4, 5, 6, 7, 8. You also have 8 electrons first that are added to the third energy level. Eventually, you'll add more, but you'll be able to use the periodic table. So let me show you. Here it says, use the periodic table to draw the Bohr model for the element arsenic. The element arsenic is element number 33. It's all the way down here in the periodic table. So what we'll be doing is we'll follow the rules of the energy levels. So that'll work. I'll have to stay there. There it is. So the first, we'll pretend that helium, so here's helium, is sitting right here, so it's a little easier to see. But we'll have 2 electrons here in the first energy level. So the first energy level has 2 electrons. The second energy level will have these 2 and these 8. The third energy level will also have 8, these 2 and these 8. Now when we get to the fourth energy level, the fourth energy level will actually begin filling up, and then we'll go back to the third energy level. As you'll see, these right here actually belong to the third energy level. This is still part of the third energy level. That's a little strange, but those 10 will belong to the third energy level. If I I'll try to color code them so it's a little easier to see. So now arsenic has plus 33 in the nucleus, and let's draw a bunch of energy levels. So I'll go ahead and draw 4 energy levels in this case. Here are the energy levels. So the first electrons for arsenic will be 2. The first energy level has 2 electrons, so we'll draw 2 electrons here. The second energy level can have 8, so I'm going to draw 8 electrons in the second energy level. I'll go ahead and double them up eventually. And in this case, what we've got is 10 electrons total. Now the third energy level, first the periodic tells me that the third energy level gets 8 electrons filled in. So I'll go ahead and put 8 on the third one as well. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 electrons. And then I'm going to go to the fourth energy level. Now the way I'm going to do this is I'm actually going to put 2 electrons in to the fourth energy level, 1, 2, and then I'm going to go back eventually and add the third energy electrons. So now I'm going back and adding 10 more. Notice I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll go ahead and put 10 more here in the third energy level. So I'll do 1, 2, 3, 4, 5, 6, 7, 8, and I can maybe put 2 more here. 1, so 10 more. That gives me a total of 18. And then I'll go ahead and go back to the fourth energy level, and notice here I have only 1, 2, 3 more electrons to add. So I'll go ahead and add 1, 2, 3 more electrons. And that is the way it's done. Now, if this is a little confusing, don't worry too much. You can go ahead and add them just the way we've done it before, but this would be the Bohr model for the element arsenic. Alright, and this completes for us. Go ahead and try one on your own. Try ruthenium, and then we'll do more of this in class.